Welcome back, Internet. Keeney coming to you with a case study, a twofer case study today. The world brings to us the 2014 Ford F150. It has the 3.5 liter turbo engine. It also has a few go fast parts on it. And it has a couple things. It's got a few things, a few check engine lights, but specifically, he only cares about two this round, or two issues. The first issue is the service 4x4 light is on, and the second issue is a new code. He monitors codes as he drives. A new code for a P1839, something to do with the turbo solenoid or something like that. I suspect we're just going to probably jump into, go to the 4x4 issue first. We will pull codes on it. We will look at service information, pull some wiring diagrams, and get on after it. So here's our modules, and we've got USB, front controls, stuff we don't care about, PATs, here we go. 0035, and that's a high voltage. Hopefully that'll be pretty easy to figure out electrical wise. So he doesn't care about the cat codes and doesn't care about the evap codes, but does care about that transfer case shift motor circuit issue. So let's go start digging around. Well, all things considered, or famous last words, this should be a super easy diag. Takes us to pinpoint test B. Says it doesn't shift right, refer below. Normal operation, the MSS, which is our mode select switch, it's the thing on the dash actually spin, communicates to the transfer case control module. Transfer case control module controls a clutch and the motor, and that's pretty much the extent of it. If we scroll down just a touch to this 1839, it basically says when pin 4 or 5 detects an open circuit. That's the extent of it. So we got our mode select switch to our transfer case control module, and then from here, transfer case control module to the actual transfer case. There's our clutch. Looks like it gets power. And then here's our motor, and it said pins 4 or 5, which are those two. So pretty straightforward. I got the truck on the rack at the moment, so it's a little tight getting in the door over there. I would like to go to both the transfer case control module, but it's in the driver A pillar and the lift's there, but I also need to get underneath of it to test the motor. So I think we're just going to go right down to the motor. We will probably just stick a scope on those two motor wires, and then maybe a test light on those motor wires and see if the motor's just open. This one might be easy. I actually lied to you. Before we crawl under it, we'll just make sure the switch works correctly. Two-wheel drive, and then I'm going to hit this to 4. So it looks like it wants high. I don't hear anything underneath either. Oh wait, I heard a click underneath. Yeah, something's clicking underneath. But if something's clicking, but I don't hear like the motor moving, so I'm wondering if it's that clutch. I'm wondering if it isn't this clutch that's engaging, making some noise. So, all right, now we know at least that works, and we should have good comm to transfer case control module down there, and we'll go underneath over. Right on. Looks like transfer case control motor. We got a 16-pin connector. We've got scope A, or lead A, on the clutch. B is on 15 and C is on 14. So those are the three we're looking at. The A, our average voltage down there. Channel A is essentially ground. And then we've got 8 volts, which is kind of a weird number on both of the other two. So now I'm going to spin that scope around. We'll go up, we'll hit the knob and see what changes down here. I don't want to pull that connector out yet, just in case our connection issue is in that connector. We're going to make sure we catch it correctly. Scope is rolling. We'll step on up and hit our 4 high. Heard something click. We got a couple changes. We will come and hit run, which is actually stop. Oh, that's interesting. how did it pull it? Let me process this data. All right, it looks like it's actually working, at least the control side, like it should. It looks like we're taking blue down to ground and purple or red up to 12 volts. Right now I've got our cursors dialed from like where it was to where it went to. So it was at 8.7, went up to essentially 13. We got a charger on it. I'll pull the cursors. Let me see if I can just switch these. So this one was there and is now here. So was essentially 0 and then moved to 8. That 8 number is weird. I don't understand. Excuse me, I read that backwards. It was 8 and then went to 0. The 8 number is a little odd. Maybe it's just, we'll switch it back the other way and see if it actually goes to 12. But nonetheless, we've got a ground, we've got a positive. That should make the motor work. I probably should have put a current clamp on that as well. Let me go ahead and do that. Current clamp is installed. We'll go ahead and switch back to 2-wheel. And back to 2-wheel. I heard a click. Oh, I'm falling. And we had a little bit of something. Let's hit stop. And let me process that. These are screenshots. So last time going into 4, we had a blue low and a purple high. Next one is the inverse. So we go from our 8 to essentially 12. And then we go from whatever it was, 8 to 0. And we are getting some current flow. We have a peak of about like 9 amps. So it's the lower one. It's like 9 amps, and then it's flowing a constant like 1 amp across it. So we are getting some current flow. That is not an open circuit by any stretch of the imagination. We also have no apply of this clutch, which is a little interesting. At this point, I'm going to have to, it almost looks like it tried to reverse it there too. Oh, it did. Maybe. I think at this point we're going to stick a test light in there just to make sure. Well, if we've got current flow, actually, if we've got current flow, we know that the wiring down there is good. Otherwise, we would never have that current flow. If we had a corroded connector or something like that, it would never reach 9 amps. 9 amps is plenty of current, even if it's just for a moment. Let's go and disconnect that connector and take a resistance measurement. Well, in this moment, looks like we have 1 ohm of resistance. Carefully holding these wires in there, go to the motor. I do think 1 ohm is a little low. Let's go ahead and run a test light in here. Before we run a test light, connector's unplugged under there. I want to see if this fault will set with the key on engine off, or if you actually have to actually rotate the knob. So we'll check our current codes right now. So we've got contact plate, that one's new, 1839, that should be our original, I do believe, if I remember correctly. Let's go ahead and clear these and see if they both come back. And contact plate, so that one's new, so we'll go back. We will read codes one more time. Read codes, continuous. Probably should do the other one too. Okay, in this case, we do not have the return of the motor code. So that's interesting. So now let's go ahead and actuate the motor. So let's try and put it in 4-wheel drive. So it's 2 right now. We'll flip it to 4. Obviously nothing's going to change. Oops. And then we will come back, hit clear, get our stand, continuous memory. There it is. Shift motor circuit open. Okay, now we know how this works. Let's go ahead and clear it. And then we'll reread it. And then we'll, if it's still gone, because it's, trying to be in 4-wheel drive right now. Ooh, it didn't clear. Or I screwed it up. Maybe it will not go away now. Interesting. Okay, let's shift back to 2. This will be good. If the motor was completely open, it'd be a lot easier, but the motor's got that 1 whatever ohm, and I don't know what the resistance value is supposed to be. I guess we could see it for it off. There's a spec for it, but since we don't know what it's supposed to be, it's a little concerning. One more time, clear codes. Okay. Okay, so if it's in four-wheel drive, it's doing that check. If it's in two-wheel drive, it does not do that check. We'll read it one more time. Excellent. Excellent. That's just the contact plate. Now we will stick our test light in there, see if it illuminates, see if that code goes away. You are propped up. There is our 4-amp test light. I'm going to try and move real fast so I can see it too. We're in 2, now 4. What do we have? And I don't see anything. Let me replay the video. So I've been trying a couple things. It appears I cannot get the load correct to make that thing work. Tried going in output controls, like here's that clutch we were looking at. It seems to be working, dialed at 47%. We still got the scope lead on it. Yeah, it says 48%. That's what it's doing. So that stuff works, but I can't find a specific control for the motor. Let me keep trying to find a resistance that will trick this thing. If anything, I may have to just plug it all back in if there's another code setting and then cut the motor wire just to be 100% certain, because we really want this code to go away to make sure that's our issue. The 1 point whatever ohms is, I'll also look for a spec for the motor resistance, because that 1 whatever ohms is not open, so we need to be for sure. All right, well, we got a little science project. He is trying to get resistances and stuff to mimic the actual motor. I cannot, so apparently we're going to pay Joe's Electric a bunch of money and get one of his boxes. But I did find a couple things interesting as I continued on. So right now we have our test light just back probed in there. This motor will work. When I actuated the scan tool, I was a dummy and misunderstood what the scan tool was telling me. So if you go into actuator tests, CCW relay and CW relay is counterclockwise and clockwise for the motors to spin, and my mics are done for that thing. So if I actuate those test lights, so we know we got a good power down here, and I actually was able to get it to where the drive shaft would lock up. So right now the transmission is in neutral, and if I spin this drive shaft right now, the rear one, this one here is spinning, but the rear one's not. So we're in two-wheel drive, and then I will hit this. I forget which way it goes. I think we'll just pick one of them. Probably shaking all over the place too. You're gonna have to deal with it. We'll hit the on button. We got a light, and then you can probably hear it click. Now the rear drive shaft is turning when I turn this front one. But so now let's turn that off. But that only moves the motor one way. It doesn't move back the other way. Now, by the way, I don't know if I showed it. Oh, there it did its own thing. Now it just moved itself back into, I believe, two-wheel drive. So we will spin the front drive shaft. Yep, rear drive shaft is not spinning. So it moved itself back into two-wheel drive. And if we go and read codes, we will see we've got the motor circuit and two others. Ooh, that says clear. No, we want to read. And they're the switch positions. Well, that's interesting. Before those things were set. Oh, wait, maybe it was if I set, we actually go and move it to four-wheel drive. So move it to four-wheel drive. It's in four-wheel drive now. And then we read codes. We've got some switch position faults that we did not have before. So now we'll go back, read codes again. There we go. So we've got the contact plate, which is what we saw before, but we saw it when that connector was unplugged. This connector is plugged back in now. And so we are going to now, since we can get this motor to kind of spin, now we're going to look at these switch inputs, because this is going to be what it's used to set those faults. We've got 4 ins and then 1 signal return, position return. And so if I unplug this connector, all these should be, 5 or 12 volts or whatever, and then this will just pull it low. So that we can actually test. And if we spin this, motor one way or another, and these are not all changing, then we can confirm this issue is in this motor assembly. And it is a motor switch assembly all in one. So that's a test I'm going to set up. Okay, we've made progress with the scan tool. This is a way better way to test this. Right now we're in two-wheel drive, so front drive shaft moves, rear drive shaft does not move. The CCW counterclockwise. The switch up top is in two-wheel drive. When it's in two-wheel drive, when we turn this on, the truck goes to two-wheel drive, essentially, so it's staying there. We're going to add our switch positions, calls them A, B, C, and D. You can see they're all open. And so we will hit on. Boom, test light is illuminated. We will spin this up, but the motor did not. Oh, wait, this is two-wheel drive. Right. So nothing changes. We're in two-wheel drive. Let's turn that off. The test light went out. That's right. CCW is two-wheel drive. Do the same thing. CW clockwise. And this will put it in four-wheel drive. We'll do the same thing. Add our data PIDs. So we got our 4 data PIDs added in there. Now get ready to hit on. Test light illuminated. And boom, now we're in four-wheel drive. So rear drive shaft is spinning. And looky there. All of the switches are still open. This, we can now just test with this. We'll just unplug that connector, and if all of those switches have like 5 or 12 volts on them, we know they got power, and our problem is right there. All right, we have test light that's connected to ground from up above. I'm going to disconnect that connector. You are going to watch all of these things, and I will call them out as I do it. Also bounce to the scope. I'll do a scope read first. Okay, connector is unplugged. Everything still says open. We're going to use channel A to check our switch status. The first one we're going to check is position 1 or switch A. So right now all we care about is just channel A. We'll move it down a little bit. It's 16 volts at the top. And we'll pick our first one. Boom, look at that. So this is switch 1. It has power down here, which is good. Let's go to 2. There we go. There is switch position 2. I will check 3. Boom, there's switch 3. And last one will do switch 4. There's switch 4. So all four of these have power coming to it. Now we are going to one by one take them to ground through a test light with the scan data and make sure the transfer case control module reads them correctly. And if they do, then we know we've got a motor issue. All right, well, this should be number, I think this is switch 4, so lower right-hand corner. We will take it to ground. Oh, look at that, it's closed. All right, now we will do switch 3. Oh, I tried. Oh, there it is. I got a loose connection. There it is, right there. There's switch 3. Now we'll go switch 2. Oh, wait, is this switch 1? Oh, this is switch 1. I got them in a different order. My mistake. Now, the next one should be switch 2. Maybe. Boom, switch 2. These switches, all the wiring's good. We are done. That is our diag for today. It needs one of those. That was a little more complicated than I actually thought it was going to be. Final wrap up on four-wheel drive shift motor actuator thingamabobber, just in case what just happened wasn't clear. I wanted to try to put some better words to it. In a normal scenario, when you roll the four-wheel drive knob, the motor spins and moves the stuff inside. These switches are going to open and close accordingly, depending on the actual position that the motor and transfer case are in. When we actually get it to move into four-wheel drive, we know it is because we saw the front and rear front and rear drive shafts rotating together. None of the switches changed at all. So then the question is, okay, do the circuits for the switches work? That's where we took test light, touched it to ground, saw it on the scan data, confirmed for sure. All the wiring is good for all of these. We don't have any issues there. The switches are not functioning correctly. I screwed up. Just now realizing it. I have one more stupid test. I did not check this wire here. If this wire is not grounded, certainly none of these are going to work. Let me go. I'll go test it real quick. Well, I could not have given you a better example if I had tried as to why we test everything. So we are on this return wire right here at the plug. It's in the middle. We got 12 volts on that wire. And there ain't no way we should have 12 volts on that wire. There's a small possibility you could have 12 volts, if all these are open, and they were all open. But let me show you what happens when you take a test lot connected to ground and touch it right here. So I'm going to just stick this test lot in the back of there. We'll watch the scope, and we will see the scope drops out to ground. And, well, of course, the test light isn't, well, no, the test light is not lit. And so the 12 volts that is on this wire is a weak 12 volts. But let me show you this next thing. Now, if you will recall, we had several codes that were set in transfer case control module. We're going to do it. Oops, it's the wrong button. It's looking through your camera. We are going to do a fresh code clear. So fresh code clear. Okay. We'll read the codes. Continuous memory. We keep getting those rotary codes whenever we do the actuation. Now that there's no codes here right now, let's go back to our live data. And then I think it was our switch. Let me pull this up. Okay, we have our 4 switches graphed, which is interesting that they are all open. Let me show you why, and that we're not getting codes for this before we actually try to actuate the motor. All 4 positions open. We've got our lead in there. Test lot still connected to ground. I'm now going to touch that test lot into where that 12 volts would have been. So touch in like so. Look at this. We have 3 switches that have closed. 3 of them. That means that there's an issue on this circuit for certain. Now, what I'm going to try to do, because the car's still in the rack and I can't get to that transfer case control module very easily because the door doesn't open, I'm just going to leave this test lot plugged in here. We're going to go and actuate the 4-wheel drive and see if any of those codes go away and then which one of these changes well. So let me set this up. All right, we are in 2-wheel drive, spinning front drive shaft. Rear drive shaft is not spinning. I've already forgotten which way is which. So we are counterclockwise. We've got our 4 switch positions, so closed and 1 open. We will go ahead and hit on. See that one switch? And I heard the motor. Actuate. So now we will spin this drive shaft. And still no 4-wheel drive, which is fun. So we'll go ahead and turn this one off. I didn't really hear, but this one didn't switch. It didn't make the same level of noise. Well, let's back on out of here and do the other way. Actually, I lied to you. Let's go right back into reading DTCs. Oh, so we do still have codes. So contact plate, contact plate, contact plate, and contact plate. Interesting. Oops, the tool's falling over. Very interesting. So let's actually we'll do one more. We're going to clear these. And then we'll do the clockwise selection. See if codes come back. Oh, now it won't clear out. That's interesting. All right, well, we'll jump back into X-ray test. Clockwise, okay. Add our data. Already got them selected. So same position. So this one changed the last time. Now it's kind of stuck. So we will hit on. All kinds of stuff moved. And then we're now We're now in 4-wheel drive. So we'll turn this off. That's interesting. I wonder if we have to exit because it didn't go back in the way. So previously when we were doing this, I had that test light hanging and it would activate it on its own after a few seconds of backing out. But it looks like it's not doing that on its own this time. And we are still, we're still in 4-wheel drive right now. We'll do counterclockwise one more time to get it in 2-wheel drive. So I'll just hit on. I just heard the motor. Holy man, that was loud. Right off. So definitely heard it. It definitely moved. And then, but we're still in, oh, there it goes. So now we're in 2-wheel drive. Now I'm going to clear code. Let's go ahead and try and move it from the top and see if it changes anything, like from the actual shift knob on the dash. I don't know if we have to key cycle, but these codes will not clear right now. Let's still just go up and try it up on top side. Okay, so a little bit unique behavior. If I unplug the test light and all the switches are open, these codes will clear. With the test light in there and some of the switches closed, these 3 codes keep coming back no matter what I do. In this moment, we do not know if that 12 volts is coming, well, it has to be coming from here, you would think. So let's go ahead and unplug this connector with the scope installed and see what our voltage is on this wire. Because what we're probably going to have to do is see, because I'm questioning, when we ran this to ground, these switches, are going to, see, this is what's weird. I don't think there should be 12 volts on here. There shouldn't be, because we have 12 volts here, 12 volts on any of those. There's no voltage difference, and so it wouldn't work. You have to pull these low. What we're going to do is we're going to unplug this connector, see what our voltage is, and then what we probably will have to do is ensure that this wire is good to the transfer case control module. So we'll probably have to access pin 5 here and see if our voltage is the same to make sure we don't have an actual wire issue somewhere in between. Well, check that out. We are disconnected in our plug and we have dropped down to 0 volts. That means that 12 volts is coming from the motor side. So this is the vehicle side that goes up to inside the vehicle. Let me front probe this real quick just to make sure. And my voice is all goofy after I just ate. So now these are pretty cavernous. So those are like the big round circle plugs. So we're in there for sure. And we're at 2.3 volts. And so it seems like the transfer case control module is putting out 2.3 volts. And we're getting a 12 volt feedback through this motor somehow. That is very strange. Let's see if it'll carry current. I know that this camera works probably terrible because I'm underneath this car. So we got a 1/4 amp test light. Now hooked to positive. So this is looking for ground. So it finds ground to a light. We don't know. There should be ground, but I mean it should be pretty low current. Might have to get an LED test light. And so our pin is this one right there. We have no light. Let's get our scope on there too. Let me set it up. All right, we're back probed in there. Scope is at the 2.3 volts or whatever. And then the other end of this test light's hooked up to positive. I will just touch on this pin, make sure we have contact. Again, it's a big round pin in there. And you'll see we jump up to 12. That is, so it's not a strong ground. This is just a very light signal ground, it appears. I really think we need to go to the transfer case control module and make sure this voltage is the same as output from the transfer case control module. So we are in a moment where service information might be wrong and is less than helpful. I've been doing a bunch of trouble-tree reading, description operation, make sure I'm not missing something, but I will get you caught up to where I'm at, and then I think we're going to make a call I gotta walk you through this. So the down, we have two scope leads right now. One pinned into the return wire of the rotary switch at the transfer case control module on the A pillar. We moved the vehicle to the 1900s technology, so we got it up on jack stand so we can make sure we know what position everything's in as far as transfer case and whatever. So we got one scope lead, channel B on transfer case control module turn circuit, and we got another lead down on transfer case motor. Same lead, voltages are the same. Let me just show you. Transfer case control module is behind and above the body computer. Here's the body computer, and that blue lead right there goes to that box, and that's our transfer case control module. Our scope leads, we're at 12 volts on both of those. Now let me roll under. All right, now we are back probed in. I'm going to disconnect this. We still have our 12 volts. I'm going to go ahead and disconnect this, and then we'll watch that voltage. And I'm just going to have to lay you down on what you're going to be seeing, because I need two hands to do this. Okay, disconnected. And there. So we have our drop in voltages. We are still pinned in, and now we are at well, that's hilarious. One you can't see, but the mean's wrong on yellow. But anyway, they're both at about 2 volts. This scope's a little buggy. Here's a bug for you. It says the mean's at 10 volts, but we're right at the arrow, which is ground. So let's see if we can stop this. There we go. There it goes. Now the mean just changed. Now it's at millivolts. Actually, we may not have a good connection there. Let me make sure we're pinned in. Alright, so we just had a lost connection during the unplug. Now we got the same voltage for both. We got 2 volts, 2.5 volts or so. 2.5 volts is coming from the transfer case control module, which means the 12 volts is coming through this motor somehow. So this is going to be important. I'll face the camera at me. I actually think we have 2 issues, a legitimate 2 issues. I think the motor has some switch issues with the rotary dial, and I'll show you that in a second. But also, I think the transfer case control module has lost its ground on this return side, because the only way that 12 volts can be coming through this circuit is if one of the switches are closed, and if there's no position return that actually goes to ground in the transfer case control module. We have two separate issues. So let me look here. In the scan tool, all these switch positions are open. And they are open because we already tested it. The TCCM sends out 12 volts on each one of these wires. And when one gets switched to ground, which we grounded manually, they will go to closed. So right now they are all open because this connector is unplugged. But even when we plug this connector in, they stay open. And we know that the thing works because we manually ground it. So let me show you this too. And when we ground it, the switch position, when we ground this wire through a test lot and we do the clockwise, counterclockwise spin of the motor, these switches change positions. And we see those positions change here. So we know this voltage is getting pulled low, corresponding to whatever switches are being closed when we manually ground this. This thing seems to have lost its ground. So if it doesn't have a ground, perhaps actually, before we make a bad call on this, we'll need to check powers and specifically grounds on this one. And actually, that's exactly what we're going to do. So I'm going to just catch you back up, because I know we've been all over the place on this one. Everything's open because the connector's unplugged. We will plug the connector in. Everything will remain open. All right, so we are open. We are unplugged. We're going to dance the phone around all over the place because I need 2 hands. And we are plugged in. So now it clicked in place. We're plugged in. Everything is still open. Now we're going to take our test lot. We'll ground our test lot just to the exhaust. take our test lot and back probe this one here. Whoops, maybe. Back probe. Well, my clip just came off ground. Alright, so now it's grounded, and boom, we have our switch positions. Furthermore, we are in two-wheel drive. Now check this out. So, front rear drive shaft moves, and the front drive shaft, I don't know if you can see it. So I'm turning it, is not moving. So we are in two-wheel drive, and the switch up top is in two-wheel drive. And A, B, C, D, our switch positions are closed, open, right? A and C are closed. This is important. A and C are closed. Here's our table of what it's supposed to be. In two high, we should have closed, open, closed, closed. And we're in two-wheel drive because the front drive shaft ain't moving when I spin the rear one. And the shifter, the Prindle shifter, is in neutral. This means our switch pack is broken as well. That is reading incorrectly. And I'll show you this even further. So when we will go back, I'll just do this all in one cut so you can see. We're going to do our output controls. And then I'm doing my best on this phone recording. We'll do counterclockwise. Counterclockwise is two-wheel drive. And then we will add, oops. Oh, my phone is dying. So we're going to add our four channels, closed, open, and then we're going to hit on. And so it's on. We're still in two-wheel drive, so rear drive shaft moves. Front drive shaft is not moving. I'm moving the rear one. So confirmed two-wheel drive. And those switch positions, man, I'm all over the place. These switch positions do not align, so we'll turn that off. This is counterclockwise. We will back out of this. We will now do clockwise. This will rotate the motor to put it in four-wheel drive. I do not know if it's four high or four low. Doesn't matter in this moment, and I'll show you why. So we got our four PID selected. Same thing. Closed, open, closed, open. And then now we will hit on. Just heard the motor run. Now it changed a few times, but now it's closed, closed, open, closed. Closed, closed, open, closed. Rear drive shaft. So now it's difficult to turn, but now, oh, it's difficult to turn. We are in four-wheel drive for sure because the front drive shaft moves, even though it's probably hard to see on camera. But keep in mind, closed, closed, open, closed. Go to our spec. There is no such thing as closed, closed, open, closed. Does not exist. And so either service information is categorically wrong, and or the switch positions in here are wrong, which explains why we keep setting the rotary switch codes every time we get a ground here. And this wire has no ground at the transfer case control module. We have two issues. We have a bad motor and a bad transfer case control module ground. So let's go to the TCCM and check our grounds. We just made all our checks. 4-amp test lot. We got a couple grounds here in this connector, and we checked powers, and the power on this one. The module up in there has all the powers and grounds. We know it has communication because it's obviously talking to the scan tool. There is no ground circuit on the signal return wire or the rotary switch. We have two issues on this truck. And so this makes me question in this moment, do we have two issues or service info wrong? Because what we've got here, this is what sucks. And we are almost going to be making a small guess. And here's why. The question is, the rotary switch in four-wheel drive versus two-wheel drive, no matter what we're doing, it does not match service information. So either the service information is wrong or the motor's bad. Okay? We do not have ground on our signal return. So we either don't have ground because there's no ground, as in the module doesn't have a good return ground path inside of it, or it detects that the rotary switch is in the wrong position and maybe turns that off as a default, because here's what makes me question that. If we put this thing in two-wheel drive and we do not provide a ground path to the signal return wire, all of the switches stay open and no code set. There is no combination of two-wheel, four-wheel, four high, four low that have all switch positions open. And so that should set a fault, and yet it does not. Now, does it not set a fault because it's a default mode or because the module is bad? I'm not 100% sure. And I will also tell you, oh yeah, this is a piece I kind of forgot to tell you also. If I go through the trouble tree for all of the rotary position switches, that codes that come up, never once does it say to go back and replace that motor. Which, how could it not? The motor doesn't match the table. But every, test this. If yes, go here. If no, go there. Like, I went through those, and every one of those say replace the transfer case control module. I kid you not. And so this one is a little puzzling. We have two issues, but I don't know if we've got a chicken or the egg, or a one issue and a reaction, or what. And I don't like that. So I'm gonna have to ponder on this for a little bit and figure out what direction to go next. We have confirmation of two issues, but I don't know why we actually have two, or one cause the other. That's where I'm at. So I'm just gonna have to think about it for a while. Furthermore, all the codes that are setting are wrong. So right now we have no codes. I'll just show you. So to the continuous memory codes, no DTCs. We're in four-wheel drive. So now we will switch to, we were in two-wheel. I'll switch to four. I'll come back here and refresh this. So read continuous memory. Now pay attention here. Contact A shorted to ground, B shorted to ground, C shorted to ground, D shorted to ground. This is where it gets important. All of these are wrong. Contact plate ground return open circuit. If this is open, then all of the switch statuses will be open. And if they're open, they cannot be shorted to ground. Specifically, when I say open, arrive data, go to our switch positions. All the switch positions are open because there's no ground. If they're open, there's no ground. They cannot be shorted to ground. But the positions still don't match the service table. This thing needs two parts. I think what I'm going to tell the client is, listen, we got two parts that it needs to be replaced, and I'll give him the choice of which one he wants to install first, just in case it happens to fix it. But we have two issues, and the codes are wrong. So thanks a bunch, Ford, for setting all the wrong stuff. Appreciate that. Oh, and yeah, the very last thing, we never got the motor open circuit to come back either, and the motor's always working every time we either run the switch up there or do our output control as well. So, only last thing that I didn't check or forgot to check and just did was pin fitment. And things are super small. The pin fitments on the return wire are fine, so appears that we've got a bad module, and according to service information, also a bad motor. So spent the night, sleeping and thinking on this old truck. Come back to it today, and I wanted to do, one more test. Welcome to the one more test channel. When we are actuating the motor with the scan tool, clockwise, counterclockwise, I don't actually know, because the switches don't read right, I don't actually know what position the motor's in. And so at a minimum, it should have three positions. It should have a 2, a neutral, a 4 high, 4 low. And if we're just spinning that motor all the way, I questioned last night if it spins all the way, if it spins past what the table is supposed to be. And so, whereas, we'll say a 180, you got two wheel, and a 180 is a 4 low or something like that, somewhere in between, as it makes that sweep, the switches will change. And so I was going to do a screen record of doing a clockwise, counterclockwise with the scan tool and see if any combinations thereof match the table. And perhaps we're just driving that motor to its full clockwise or full counterclockwise position. And if that would have been the case, perhaps it's just not a normally operable position that it could be in. And in getting ready to do that test, I have a new result that we have not seen before, and I'm going to do my best to duplicate it, so pay attention to this. All right, right off the bat, shifter is in two-wheel drive. Let's go ahead and roll under this old thing to the best of my ability. And right now, this is a rear drive shaft. It spins. Front wheels do not move. Front drive shaft does not move. I'm spinning it. So we are in true two-wheel drive. Now, while we are in true two-wheel drive, there are no codes. So, transfer case control module there at the bottom. Retrieve continuous. No codes present. And this next thing that I think is an issue with the motor itself, if we get our switch statuses, okay, they're all open. Now, let's go back up top. This is the new result that we did not have previously. We're just going to move this to four-wheel drive. Come back underneath. And now we are in four-wheel drive. So the front drive shaft, man, this thing's stiff. Front drive shaft is turning, front wheel's turning. There you can see the front wheel move out. We're in four-wheel drive for sure. Look at this. All of our switch statuses are still open. And this is what was weird. When I did this last time, there were no codes. Look at that. No codes. To me, the only thing this tells me, the motor's actuating, but this transfer case control module is smoked. It's not setting codes when all the statuses are open. It doesn't know what's going on. To me, that's a module issue. And then I'm still going to do the clockwise counterclockwise test where while we ground. Actually, in this moment, let me grab a test light. We'll ground it because we know it's in four-wheel drive. I'll ground the return circuit and see if the switch combinations match the table. All right, all switch positions are open. Nothing's changed. Still in four-wheel drive up top. We're just going to touch in our test light that's connected to ground. And we have B and C closed. See, that still doesn't match. So I'm trying to get this test light set up so it isn't going to fall on us. B and C are still closed. That still doesn't match when we get the table. Oh, I was wrong. Now it is matching the table. So we've got an open, closed, closed, open, which is 4 high. That means that thing is reading correctly now. But only, now what codes do we have? Because we should be setting faults. Well, now that, open, closed, closed, open. Oh, right. Wait, open, closed, open. No, am I going crazy? Yeah, open, closed, open. So we're in 4 high. So it's reading correctly now. That is trippy. I don't have the confidence to throw a motor in this moment. I think we need a transfer case control module. Read codes, continuous, and then we've got our contact plate issues. Interesting. I'm going to play around with this a little bit more, but in this moment, I do not have the confidence to replace this motor. I think we have a transfer case control module issue. I'm just going to go ahead and record it. So same position, open, close, open, 4 high. We got the test light in, so we will pull the test light out. We will see everything has gone to open. Now let's see if we can go back and clear codes. We'll just hit the clear button. Yes. Okay. and then read, continuous. I wonder if we have to key cycle. So those are still in there. Yes. Let me do a key cycle and see if that changes anything. The only thing we have done is a key cycle. Let's go ahead and see if we can clear these codes. Oh, hit okay. Codes are gone. And we are still in four-wheel drive. And our test light is disconnected. Live data. All the way at the bottom. And okay. Those are all open. This, I got to call it transfer case control module, but I still don't understand why the motor circuit was open. We still had a motor circuit open to start with. Is that because the module was bad, or is that because the motor is intermittent? Now we still question this motor. For sure, need a transfer case control module, and the motor is questionable. We do not know. Let me do the force clockwise, counterclockwise with the screen record and see what combinations all of those change to. All right, we got our screen record going, and we will do our actuator test. Right now, the selector up top is in two-wheel drive. The vehicle's actually in two-wheel drive. Front drive shaft does not spin at the rear, and so we will do counterclockwise. Actually, counterclockwise is two-wheel, so we want to do four-wheel. Hit OK. We're going to add data stream PIDs. Select these four. And now we're going to record this. So now my test light is not stuck in. I'm going to stick the test light in. Those should change. They do in fact change. So this is test light. And now we're going to go and hit this thing to on. I hear it. Now it's locked in. And we are in four-wheel drive for sure. Let me hit off and then see if anything changes. Nothing changes because I think it just drives it. And now we'll go ahead and hit stop. And then I'm going to review this footage and see if any of those changes along the way fit our table. Well, if that voiceover was successful, you would have seen the same thing that I saw. No matter the transition from full counterclockwise to full clockwise, does the table match what the scan tool says? Is it possible that the transfer case control module could still be misinterpreting each one of those switch positions because it's bad? I guess that's technically possible. However, we tested that one circuit at a time and it responded correctly. So in that case, like I don't see how we have one issue or the other. I'm back again to we have two issues and a client that's coming in. Well, sometimes things just don't make 100% sense. Let me show you what we got going on here. We have replaced the transfer case control module. We have not replaced or even plugged in the four-wheel drive motor assembly, and the truck seems to be fixed. Let me show you. Old module. New module, just kind of drug out of the way. Our scope lead is on our position return, which always had 12 volts on it before. Cars driving by. Right now, we have 0 volts on it, so the little little arrow thing there is 0 volts. We're at 0 volts. We're actually at 0 volts, and it actually carries a small ground. So this is when I'm using like switch stuff. I like to use like super low voltages. I like to use an LED test light. So this LED test light is hooked up. I was looking for ground, so when it fires ground, it will light. And so I will just touch that in there. Hopefully you can see, get my hand. So it lights up. You can see we got a small change on the scope. So I really like LED test lights for stuff like this. For sense circuits, they're amazing. They're great for it. Figure out what that voltage is right there. Y1, you're looking about 8 volts, just standard switch stuff. But let that rerun, turn that off. Now let's go to, keys off. Let me turn the key on and get that set up. Right, two, we shall turn the key on. We're currently in 4 high because I was messing with it. We will do a fresh fault scan and no codes. Let's see. Well, in the TCCM that was. So we still have USB we don't care about. We still have tire pressure we don't care about. And the bypass circuit, which we already knew. It's been several days since we were in here last as well. Nonetheless, just the same. We'll go in this module. This is odd. This is what's odd too. It seems Ford Service Information has lied to us. I will see if I can split screen this again. We'll overlay the table from Service Info to, actually I'll just do it right here. Righto, here's our switch positions. Notice that they're neither all open for any condition. Now we will bounce back to here. We will do live data. We will do that one, switch status, modes, and then grab our 4 position switches, and then graph. And then I'm going to start it, so it's probably going to be loud, but hopefully the mics will settle. Hopefully you can still hear me. All of the switch, so we're in 4 high. Let the thing go away. We're in 4 high, and all the switch statuses are open. And I cannot explain that. We do not have any service 4x4 message. We'll go ahead and switch to 2-wheel drive. So 4-wheel drive shift in progress, 4x2, no error messages. And then what I'll show you on here is the switches only go closed during a shift. It's very strange. So again, we will go ahead and shift to 4 high, shift in progress. 4 high has been engaged, and you'll see we had another switch status change on some of these. We're in 4 high, but like right now they're all open, and so the service information is just wrong. Let's go ahead and do our 4 low. Oh yeah, so I'll just show you that the wheels are spinning. Let's see. Oh, I just dropped the top down. Let's get on it. Let's real get on it. Front wheel spinning and rear wheel is spinning. Now we will go to neutral. Oh, I forgot to turn this off too. I'm surprised it didn't freak out. Traction control off. Ease on the brakes. Make sure wheels are stopped moving. Now we will hit 4 low. Just heard a click. 4 low. Advanced track off. We are in 4 low. And again, switch states are all open. They change momentarily, but when you're actually in any of the gear, any of the 2 4s, 4 high, 4 low, the switch statuses stay open. So this is categorically wrong from service information, which is just wonderful. We'll go ahead and hit reverse. And we've got front tire movement, rear tire movement. This is a fix. We'll go ahead and hit neutral so we don't ruin everything. Then we'll hit 2 high. Watch the switch statuses change. So some of them change. And it changed more than once, which is super bizarre. We're in 2-wheel drive. And then we'll go back to, I guess we'll just do reverse because I like reverse gear for today. All right, we're in reverse gear. We have no front wheel movement. We've got rear wheel movement. And that's it. It is shifting. Oh, furthermore, so we'll turn this off. Let me take you over to the new motor real quick. Okay, this is the new motor from Ford. We did not install it. We didn't even plug this into the car at all. But we're going to do resistance check on the motor circuit wires as we get the glare away. And the motor resistance here is the same as the one on the car. The one on the car was like 1.1.5 or something like that. So I'm now pinned in. Look at that. Oh man, I just messed it up. Well, this is obnoxious. There you go. 1.5, 1.6 ohms. So proper resistance for one of these appears to be in the 1.5 ohm range. I do not know why we had an open motor fault to start this whole thing off. Let's also do our actuator test. So we're in four-wheel drive, or excuse me, I misspoke. We're in two-wheel drive. Key is on, engine is off. We will do actuator test. Actually, I'll go ahead and start it for this. So engine's running because I'll shift it through the gears to see if anything changes as well. So clockwise relay was two-wheel drive previously. And then we will add, and we will just look at our switch states, which we got. Okay. And again, switch states all open. Hit on. It's on. They're still all open. And we are certainly still in two-wheel drive. We know it's in two-wheel drive. So we'll turn that off. Go back. I'm trying to set this up where I can bounce back and forth a little bit here. We have to deal with the glares. We will do clockwise. I don't know what I said last time, but we're doing clockwise now. This is four-wheel drive. We're going to add our data sets. We got some blue LED glares on there you're just going to have to work with. So all open. We'll go ahead and hit the on. Maybe on. No status change. I just heard it click down below. Hit neutral, hit reverse. Probably should turn traction off. None of those ever change. And furthermore, we're in like two-wheel drive. So I don't know how this thing is working. So we're in reverse. That one's spinning. This one is not. That one is not. And that one you can see is just barely turning. So right now, with it in the clockwise, which was four-wheel drive before, it is now in two-wheel drive. I don't understand the way this works. It's very odd. So now we'll go ahead and hit off. Maybe, come on, off. Nothing changes. We'll back out of it. I just heard and felt, there we go, look, to exit. So it's doing a shift, but it's still like it's happy as it was. So we'll go ahead and stop it. We'll hit our 4 high to exit. Oh, shift to neutral. Oh, maybe we just aggravated it doing that. Okay, there's 4 high. Now we'll shift to 2 high. Yep, so now we're in two-wheel drive. Last thing we'll look at here is going to be just a full rescan because we've been messing with it. Specifically, we'll do 3 scans. We'll do a continuous memory from this module. Look at that, no codes. We will do a self-test, so we'll key off engine on, do our self-test, and then like the lights flicker and stuff when it's doing the self-test. Stuff's clicking. Oh, look at that. No DTCs, lights flickered. We'll back out of here. And then we will do a full scan one more time. Look at that. That's it. No codes. It works. We've got USB, tire pressure, and yeah, we already know about that one. That's it. It's fixed. Just needed one of them modules. So in this very moment, it seems service information is what may have taken us for a small ride here. Unless there's still, it works. Like everything works and there's no code. So I can't imagine that the motor down there is bad. I haven't driven it out on the road yet, but I mean it's sitting up on the jack stand so we can get inside the doors and stuff. It's working. I'm a little confused about the switch operation and why we had that motor open circuit code. And that was code was in there as it showed up. Like I'd never unplugged the connector or anything. Uh, I think we did unplug that connector during testing. It said multiple faults. Short answer is I don't know, but it's fixed. So as weird as some things are sometimes, this is just the way that it goes. And at the end of the day, I hope that something in here was helpful for someone out there. And we will just catch y'all up in the next video. Bonus footage for you. I don't see anything wrong with this old module. Everything looks super clean. No corrosion, no hot spots. Don't see any cracks on any of those solder joints or anything like that. So who knows why that thing failed.